Hello everybody, welcome to another video lesson. Today we're going to be looking at solving logarithmic equations and inequalities. This is something that we've done in previous lessons, but we're going to get some more practice with it today. Okay, so let's jump into some properties, some new properties that we'll be using. We've got our property of equality here. Okay, states that if we have a base b that is greater than 0, okay, so a positive base b, then that log base b of a is equal to log base b of c if and only if a and c are equal to each other. Okay, a and c have to be equal to each other. Okay, we also have the property of inequality now. Okay, if I got a base b that is greater than 1, okay, and my x is greater than 0, okay, and I have this inequality that says log base b of x is greater than y, then x is going to be greater than our base b raised to the y power. Okay. And then if I have, again, base b with an x greater than 0 and log base b of x is less than y, then my x is going to be in between 0 and b raised to the y power. Okay, so now I've got this inequality solution that says x is in between 0 and this base b raised to the y. Okay, we also have another property of inequality here. And this is showing that if I've got log base b on both sides here, this is really the main difference. Okay, so if my b is greater than 1, log base b of x is greater than log base b of y, if and only if x is greater than y. All right? And then with the same constraint, and we flip our sign, then for our solution, x is going to be greater than, or sorry, less than y, flipping our inequality sign as well. Okay? So some examples here, if I've got log base 4 of y, and that's equal to log base 4 of 16, that is true only if y is equal to 16, all right? Okay, and if I've got log base 10 of x is greater than 5, then I know that x is less than 10 raised to the 5th power. Okay, so I'm just getting that from right there. And we'll kind of show you, I'll show you why this is the case in our examples. Okay, we're going to exponentiate both of these, and we will see kind of how our logs drop out here. Okay, and finally, if I've got log base 6 of x, and that's greater than log base 6 of 5, that's true only if x is greater than 5. Okay, so that's this property right here. All right, let's go ahead and hop into some examples. First example here, log base 9 of x is equal to 3 over 2, okay? So we are going to do what's called exponentiating, which we've done in prior videos. Okay, so I'm going to exponentiate to whatever this base is here, okay? So I've got a base of 9, which means I'm going to bring in this new base of 9, and I'm going to raise everything in my original equation and bring that up into the exponents. Okay, so we call it exponentiating because I'm taking what was inside my equation and shooting it up into the exponents. Right? So now we can see that what I have here, this left-hand side, is going to reduce to just what's inside my log here, okay, which in this case is x. Okay, and then let's see if I've got a power raised to, or sorry, if I've got a base raised to some power that is a fraction, then I know I'm going to start bringing in some radicals here. So here I've got 9, square root of 9 to the third power. Square root of 9 is 3 to the third power. So x is going to be equal to 27. All right? Okay, so same thing on the right-hand side. So we've got log base 16x is equal to 5 over 2. So we're going to exponentiate with the base of 16. Okay, this is going to, I just kind of flipped our sides here, okay, but this is going to, when I exponentiate with the base of 16, we'll simplify to just x, and then I'll have 16 raised to the 5 over 2 power. So that's going to be square root of 16 raised to the 5th power. That's 4 to the 5th equals x. That's going to be 1024. Okay. Moving on, next example here, we've got log base 3 of x squared minus 15 is equal to log base 3 of 2x. Okay. So thinking about our property of equality, I've got log base 3 of x equals log base 3 of y. That's true only if x and y are equal to each other, right? Well, in this case, this whole thing here, I can think of as my x, and then this whole thing here, I can think of as my y, right? I've just got more complex terms inside my log instead of x and y. So we can go ahead and set x squared minus 15 equal to 2x, and now we just need to solve for x, right? So let's go ahead and subtract 2x from both sides, and we get this nice looking quadratic here that factors into x minus 5 and x plus 3, giving us solutions of x equals 5 and negative 3. Now we have to be careful because we are not done here, okay? We have to check for domain issues, okay? Because with logarithms, I can't have what's inside my log, I can't have a negative number, right? I cannot have a negative number inside my log. So, especially with this negative 3, I got to be careful because if I plug this in to either one of these logs and it gives me a negative number, okay, then I can't use that as a solution, right? So if I plug in into log base 3 of 2x and I plug in this negative 3, that gives me log base 3 of negative 6, right? Okay, and that is going to be undefined, which means I can't use negative 3 as a solution. So x equals 5 is my only solution there, okay? All right, example 3, we're going to solve some inequalities here. So I've got log base 4 of x is greater than or equal to 3. Okay, so my base is greater than 1. X, we're going to say, is greater than 0, right? Because, again, this has to be positive inside of here. And I've got log base b of x is greater than or equal to y, right? So in our concept slide, we saw that that is going to be equal to x is greater than or equal to base b raised to the y, right? Okay, so I can tell right away that this is going to be x is greater than or equal to 4 raised to the third power. Okay, so let's see why that is the case. Okay, we're going to go back to our original equation, and we're going to, again, exponentiate with the base of 4. Okay, I'm doing a base of 4 because my log has a base of 4. Okay, so we can see here that this left-hand side of my inequality is going to simplify to just x, okay? Just x. And now I've got log base 4, or sorry, I've got 4 raised to the third power on the right-hand side. So I've got x is greater than or equal to 4 raised to the third, which is going to be 64, okay? X is greater than or equal to 64 in set builder notation here. Okay, so now I've got a log base 2 of x is less than 4. Okay, so we've got a b that's greater than 1, a base that's greater than 1. We're going to say that x is positive again, and now I've got the log is less than some constant here. So that should be, we should get 0 is less than x is less than base raised to the y power. Okay, so again, let's see why this is the case, and we're going to use exponentiation again to solve this inequality, okay? So we're going to have a base of 2, okay? And we're going to take our original inequality, shoot it up into the exponents of this new base of 2. This left-hand side here is going to reduce down or simplify to just x. So I'm going to have x is less than 2 to the 4th power, okay? Now be careful because we are not done here, and why is that? Because this inequality solution includes values that are negative, right? And our domain for log of x is greater than 0, right? Okay, so I need to keep that in mind, and that's why we have this 0 is less than x is less than b raised to the y, okay? That's why we have that here, because of this domain constraint for our log of x, all right? So our final solution is going to be 0 is less than x is less than 16, all right? Okay, taking a look at example 4. Okay, we've got log base 5 of 2x plus 1 less than or equal to log base 5 of x plus 4. Okay, this goes towards our other property of inequality. Okay, but first I'm going to show you our property of equality. I've got log base b of x is equal to log base b of y. That's true only if x is equal to y. Similarly, if I've got log base b of x is less than log base b of y, that's true only if x is less than y, all right? So basically, I can just take what's inside my logarithms, okay, and just set them equal to each other, right? So So I've got 2x plus 1 is less than or equal to x plus 4. Okay, and now I can just go ahead. This is kind of an algebra 1 problem at this point, and I just solve for x. All right. So I subtract 1, subtract x from both sides. I get x is less than or equal to positive 3. Okay. Again, I have to think about what this includes here, right? Because this includes values of x that are less than or equal to 0, right? And these values are outside of the domain of log, right? So what we need to do, okay, is since I have not just x inside my logs, I need to go ahead and set both of the insides of these logarithms, okay, so 2x plus 1 and x plus 4, I need to set both of these less than or equal to 0, okay? We're doing this to find out what intervals of x we are going to exclude from this solution here, okay? We need to exclude some parts here. So we're going to go ahead and solve for x. So if I solve this part for x, solve this left-hand inequality for x, I get x is less than or equal to negative 1/2. If I solve the right-hand one, I get x is less than or equal to negative 4. Okay. Again, we are excluding both of these intervals. Okay. So to kind of help us visualize this, we can draw this out on a number line. All right, and wherever my intervals are that I just solved for, I'm just going to put an x by that, okay? So less than 1/2, put an x by that. Less than or equal to negative 4, I'm putting an x right there, all right? So anywhere that's not within these two intervals is fair game for my final solution, okay? So it's going to be negative 1/2 is less than x is less than or equal to 3, right? And now we did this again because we had more than just x inside my logarithms, all right? So now I can't just say x, or I can't just say 0 is less than x, right? I have to go ahead and solve these for what intervals of x to exclude, and then we go ahead and use that for our final solution, all right? So that is it for this video, guys. Nice and short one today. Good luck on your practice.